Hi everyone, today what we're going to be doing is we're going to be doing an update to a test that I have previously filmed for the channel. This is going to be a test for hydrogen, and because we've got a really cool camera available, I'm going to be redoing it and we'll see whether we can get an even louder explosion as a result. So thanks to our mystery filmer. Say hi, mystery filmer.
Hello.
Hello. Okay, so mystery filmer is going to be zooming in on this over here. So this is just hydrochloric acid, but I've actually pepped it up a little bit with some concentrate, just to make sure that we get a cool effect. Because hydrochloric acid, you've got to make sure that you're wearing eye protection when you're using it. So this is one of my favorite methods of actually getting hydrogen gas. You've got to remember just a little bit of the chemistry behind it. It's hydrogen plus oxygen, which is in the atmospheric air. Those are the two reactants, and the product is water. And what we're looking out for is this presence of water. So many people, when they see a demonstration like this, they're just taken aback by the explosion. But what you've also got to do is you've got to look out for the actual product itself. So I've got some magnesium here. I'm going to pop that in here and just push it through. There we go. I don't know if you can get a zoom in on that one. There we go. That should be reacting straight away. There we go. You can tell these bubbles hopefully going to start forming very soon, very quickly. And we're going to collect the gas. The gas is lighter than air, so it will float up. So the idea is to have the product, which is hydrogen gas, coming through. This initial chemical reaction is magnesium plus hydrochloric acid. So the magnesium chloride, which is the salt, stays behind. A hydrogen is actually the product as well. So the hydrogen that we are doing for our test today has to be generated. So the hydrogen gas is going to rise up here, and as it rises, it's going to push out the atmospheric air that's contained inside this boiling tube. So effectively what I'm doing is I'm containing the hydrogen. I'm going to collect it in here. I'm going to take a guess as to when it's ready, and we're going to ignite it using a lighted splint. So it's the interesting bit, just watching it. Around about a minute, I think I'm going to take a risk, and I'm going to try and see whether we've actually collected enough hydrogen gas. So, trigger warning, there might be a little bit of a pop, but what we're looking out for at this stage, there's nothing in the boiling tube. There's nothing up there. You can see there's absolutely nothing. Is there nothing there?
Yep.
There's nothing there. It's just a gas. Okay, there's no spray, nothing like that. So what we're going to do is we are going to set light to it. Okay, got our flame here. Ready? Fantastic. Okay, so put the flame out. Now what we need to do is we need to focus on that condensation. Okay, you see that it's like dew. Okay, historically this has actually got such great importance. So to cut a long story short, this goes back to way back to the 18th century, and the theory that was dominating at the time called phlogiston theory. So essentially, chemists at the time felt that there was something being lost from a fuel, from burning a fuel. And they justified this by looking at the ashes that would be left behind and realizing that they were lighter in the sense that they were less dense. So they felt that something was being lost from substances that could burn, and they named that phlogiston. And around about that time, the investigations that were predominantly made by a French chemist called Antoine Lavoisier, proved this to be not the case whatsoever. You see, at the time, they forgot that air actually consisted of other things. Well, they didn't forget it, but they didn't actually realize it at the time. But Lavoisier was an accountant, and what he did was he was very, very meticulous, and he conducted these in closed vessels. So he was very, very meticulous. He made sure that nothing was lost whatsoever. In the late 18th century, there was an Englishman called Henry Cavendish, and he was able to isolate this hydrogen gas. He actually called it inflammable air. Priestley, who was another scientist at the time, another chemist, noted that when this hydrogen gas and common air were ignited with a spark, in much the same way that we just let light to it, this condensation formed on the glass walls. Now, Cavendish repeated this experiment and found that the droplets were actually water. He was able to test for it. And at the time, there was this predominant theory called the phlogiston theory that explained burning by the loss of this mysterious substance called phlogiston, which didn't have any mass whatsoever. This theory lasted around about 100 years until the likes of Cavendish had a look at it. So Cavendish actually was able to explain in terms of this phlogiston. He actually assumed that the water was already present in the air each of the 2 years, that was before and after ignition. But then in June 1783, what happened was Lavoisier, a French chemist, was able to obtain this condensation in a very, very pure state, and he correctly identified that it was water. He concluded that water was not an element, but water was a compound of oxygen and hydrogen, as it's now known. And to support his claim, Lavoisier was able to get the water and decompose it back into oxygen and hydrogen. He was able to dismantle the phlogiston theory. As you can tell, here it is, that dew behind it. It's an amazing, amazing thing. And what I could do is I could test that for presence of water using anhydrous copper 2 sulfate. I've got 2 other videos on the channel, one with anhydrous copper 2 sulfate and another with cobalt 2 chloride. Why don't you go and check those out, and that will be a suitable test to confirm that this is water. Thank you very much. Thanks to our mysterious filmer. Say bye-bye, mysterious filmer.
Goodbye.
Goodbye. Take care. Thanks for watching. Give a like and subscribe.